Okay, today's lesson is 1-3 transforming linear functions. So we've already been through numerous types of transformations, but that has been kind of general. Now we're looking specifically at linear functions, and we're going to look at the actual functional rules themselves a lot more. Okay, so the first thing that we have is translations. You all know translations is where we pick something up and we move it either up or down or right or left. We could also move it both, as we saw in our very first assignment of this class. Okay, so for horizontal shifts or translations, the input value changes. You'll notice that in our formula here, it says f of x minus h. That means that everywhere we see an x in our formula, it's going to turn into an x minus h. If the number is greater than 0, so if the number is being subtracted, hold on, if the number is being subtracted, it moves right. So subtraction, trying a new method here. It's not working out perfectly with the writing, but my other method broke, so subtraction or not. I think I just have to write slower. Subtraction moves right. So it's kind of the opposite of what you would think. Addition moves left. I swear I made this an F. So subtraction moves it right, addition moves it left. Better. So if I see some number being subtracted here inside the parentheses, it means it's going to pick the thing up and move it to the right. If it if it's an addition inside the parentheses there, it's going to move it left. A vertical shift, you'll notice that it has a K and it's being added to the outside. For vertical shifts, it's what you would think. If I'm adding, it moves up. So let's just make a mark here. Addition moves it up, and subtraction moves it down. We're going to go through a lot of examples of these because it is a difficult section for a lot of people. Okay, when it reflects across the y-axis, it's your input value changing. So in other words, everywhere I see an x, I would replace it with a negative x, but only where the x is does it get changed to a negative x. These lines are symmetric about the y-axis, which means it's flipping right to left. So that flips over to there, and that flips over to there. For reflection across the x-axis, it's our output value that's changing. So we make the entire thing negative. So if I'm reflecting across the x, if I have a function, say x plus 3, if I have that function and I'm reflecting across the x, it means that I put the whole thing in parentheses and put a negative in front of it. Now I'm going to have to distribute that negative, and that becomes negative x minus 3. Whereas if I'm looking at reflections across the y-axis, if I had started with x plus 4. Then flipping it across the y-axis means that where I see the x, it becomes a negative x, close the parenthesis, plus 4. So I don't distribute that negative, and that's just negative x plus 4. That looks like a y. Better. So again, we'll do a lot of work with these. Um, just remember that anything that's happening to my x's, like even with translations and reflections, it's inside the parentheses. And if it's happening to my y's or it's a vertical thing, flipping across the x-axis vertically, up and down, it happens outside the parentheses or not just to the x. Okay, let's try the first example. Let g of x be the transformation of f of x. So g of x just means a new function. And it says write the rule for g of x. So we start with f of x equals 4x plus 5. This gets translated up 5 units. So now we know we're going to have a g of x, which is a function of x, a function called g of x. Equals then 4x plus 5. Because this is a vertical translation, it goes outside the parentheses, so it's not going in with this x. It just gets tacked onto the end. Isn't working out great with the... It's like it's freezing up. So it was 4x plus 5. We're translating it up 5 more units. So it gets a plus 5 at the end. Now we just combine our like terms. G of x it's supposed to be a curve. Equals 4x plus 10. So we just did 5 plus 5. Okay, so that's translated up 5 units. Vertical shifts, we just move it up and down. It gets added onto the end. Example 2. A linear function is defined in the table reflected across the y-axis. So if we're reflecting across the y-axis, remember what's changing. It's our x's that are changing. So since our x's are changing, our g of x values will stay the same because it's just the x that's changing. Come on, man. Thing is killing me today. G of x so we're going to have 3 values that are all the same. 0, 2, and 4. Our x's are what's going to change. The negative 1 is now going to flip, and that's going to become a positive 1. Our 0 stays 0 because you can't make a positive 0 or a negative 0. 0 just doesn't work like that. And then the 1 is going to become a negative 1. If I look at Desmos, I can plot our 3 original points, if I could remember what they were. Negative 1, 0, 0, 2, and 1, 4. So negative 1, 0, 0, 2, and 1, 4, I believe it was. And I'm going to actually just take all these and go into settings here. I'm going to make them all the same color and make them all red. Now I'm going to plot my G's that I just found. 1, 0, 0, 2, and then lastly, negative 1, 4. I'll make all those the same color as well. I'll make all those blue. And now if I zoom in on this, zoom out a little bit. If I zoom in, I can see that here I have my original line, and this one is reflected across the Y. So it's just flipped the opposite direction across this axis. And that's it. Let g of x be the indicated transformation of f of x. Write the rule for g of x. So we have 3x plus 1 translated 2 units to the right. So if I'm writing g of x, g of x equals, now if you remember from our translations, going right is going to be subtraction, and it's going to be inside some parentheses. Where the x is, you replace it with the 2 units right. So it's going to be 3, put your parentheses, x minus 2 plus 1. And so as I look at this now, I see this 3. I have to distribute that to both of these. So that's going to give me 3x minus 6 plus 1. Now I can combine my like terms. Three x minus 5. I said 5 and wrote 3. My bad. 3x minus 5. That was even worse. I need help, but not like this. Last time, I swear. So much better. Let's look at the original graph in this graph and see if we can see it being translated 2 units right. So the original was 3x plus 1. I'll just exit out all these. Original was y equals, or I can even do f of x. Desmos recognizes that as a function, as long as I do equals, and then 3x plus 1. Then we're going to do g of x equals 3x minus 5. So what you'll notice is that I had this point here, 0, 1, and now it's shifted to the right 2 units, and I now have 2, 1. So this was my original function, shifted to the right 2 units. And every point on this function is shifted exactly right 2 units. This is at -1, and now it's at +1. So we know that we had the proper function rule. Desmos makes it easy for you to check and see if your equations are right. Make sure you do it on tests and stuff, because this can be pretty confusing stuff. Okay, I'm going to give you some fairly simple examples of this tonight for homework. I want you to try it out. Make sure you show up to the Google Meet tomorrow if you don't understand.